Hello everyone, my name is Brian Anderson. I'm a Director of Technology with the Office of the CTO here at Imperva, and today we're going to talk about digital transformation and security at the speed of DevOps. So it's no secret that data is the most valuable resource on the planet. As we consider things like digital transformation with some of the new and innovative advancements in recent technology, it's important to also take into consideration the impact that has on security and how that changes the way we need to look at the design, deployment, and management of the environments that house this data. The cost of storing data today is so cheap, people are storing data everywhere. But it is getting increasingly more complex to protect this data in all these environments. Of the 15 billion records that were taken in data breaches in 2019, roughly 13 billion of those were taken through the application or API tier. This isn't necessarily due to OWASP-related exploits and attacks. A large majority of these breaches were due to inadvertent web exposure or business logic attacks. Applications and APIs do not have a consistent security posture and are exposing data in ways that are not intended, and hackers are smart enough to find the ways to access this data. Protecting data is a bigger story than just looking at the database or the file storage today. So why do companies go through this digital transformation? Well, there's a couple aspects to this. For cloud migration, essentially, it's moving away from physical infrastructure and bare metal, hardware that you had to pay for hosted in data centers, and adopting virtualization. Essentially, there is the notion of a consumption model where I only want to pay for what I'm using. So instead of paying for keeping the lights on and power and resources that I might only use a fraction of for the most of the year, only using that over capacity over the holiday season, for example, I can then only pay for what I use, being able to spin up and scale up to the exact amount of resources that I need based on the traffic that I have coming in. There's an element of cost reduction or optimization here. From a business perspective, we always make decisions to either make money or save money. So in this realm, it's more about optimizing your deployment and only paying for what you need. Additionally, with cloud migration, there's an element of global scale. A lot of these hosted cloud environments, public clouds have a global footprint that within a few clicks of a button, I can take my application and stand up a global network or a global footprint of that in all regions. And also there's the notion of supporting multiple clouds, so not being bound to one cloud or leveraging specific clouds for what they're best at, moving your analytics to one cloud and having your CPU be processed in a different one, leveraging the native cloud services for what they're best at. Additionally, there's the aspect of developer productivity. If you think about the amount of time it would take you to physically stand up all of these resources in the legacy method of doing things with on-premise, the amount of time and people and investment that it would take, the barrier to entry and cost to stand up a global network of an application like this is a fraction of what it was. Digital transformation also applies to application architecture with the notion of microservices, essentially decomposing the large monolithic application into a lot of smaller parts. This enables an organization to expedite the release cycle of how often we can push out new code and new features by only modifying a smaller part of the application and not affecting the entire ecosystem. Alternatively, I would have had to go regression test the entire massive code base of a monolithic application in the event of any code change, but now I can only manage that in smaller parts. And this also enables us to scale certain parts of the application based on the scale of resources that are needed and not affect other aspects of the application as well. The adoption of containers has also changed the way that we design and implement applications as well. It's brought standardization, essentially creating base images with all the minimum resources that are needed to run an application. I can then standardize on the way that I develop from a local workstation to a dev environment to a stage or a UAT environment all the way to production. So there are no differences between what I'm running in my workstation in a test environment versus the time it takes me to test and troubleshoot something in a production environment. There are container orchestration solutions out there like Kubernetes or Elastic Container Services like Fargate in Amazon that enable us to run containers at scale in a large production environment, essentially creating stateless machines that we can instantiate in a matter of seconds, as opposed to the legacy monolithic deployment process, which took significantly more time. Also, there are smaller components like functions as a service, where I can have tiny snippets of code that get invoked, like Lambda, for example, on Amazon, that can be invoked by almost any other event inside of a cloud environment. So I can break my applications down even to the smallest bits of code in the most micro components and be able to scale my application that way, essentially developing with much, much smaller pieces, but making it much more agile to be able to push out new functionality. We also have a newer design model or pattern called API first development, essentially decoupling the front end of applications from the back end of applications, enabling us to also create shared services. So in a case where I wanted to create one API endpoint for maybe a front end application, I can now leverage that same API by a mobile app and maybe even expose that API to technology partners or even to the public to use as well. So getting more value out of and be able to create more repeatable use of that code. Which is very, very helpful from an optimization and efficiency perspective. Lastly, we have the notion of API gateways, which introduces a technology that allows you to create and manage your APIs in a much more streamlined fashion, so not having to write the code yourself, but being able to host and manage and maintain that through a notion of various configuration files, or configs basically. And then we have fully automated deployment. Essentially from end to end, streamlining the process that it takes from committing code into a repository to maybe producing containers, or maybe sending that code and those applications out to my various environments through the software development lifecycle, from dev to staging to production, through things like CI/CD. So continuous integration, continuous deployment. Every time I make a commit, there can be pipelines that are used to auto-generate my containers and push those out to the various environments. Things like Jenkins build servers, or Amazon has a code pipeline as well. GitLab has one as well. There is also infrastructure as a service type of offerings, where you can define through configuration files like Terraform, for example, and stand up an entire region in a particular cloud. And this includes the networks, the databases, the resources, and how everything works, including security groups and levels of access and ACLs and so forth. I can define that one time and templatize that, and meaning I can stand up n number of regions n number of times, and then also reduce that back down with a simple command or a click of a button, if you will. And then configuration management systems allow me to manage configurations in bulk. If I need to manipulate or optimize or change configurations across many endpoints, many services, and expedite the rolling out of new configurations in that way. Things like Chef, Puppet, and Salt and other configuration management systems can help streamline that process as well. From a topology perspective at a high level, the story is the same. We have users coming in from the outside and users who have access internally. The business objective is to make it as easy to deploy, manage, and transact with whatever product or service the organization is putting out as possible. When it comes to application and data security, however, digital transformation changes everything. We're now dealing with a moving target. The business is rapidly adopting new innovation, and security needs to learn to adapt. The fact of the matter is, regulatory compliance requirements have not changed. Hackers are researching and leveraging technology innovations just as quickly as they are coming out. Considering all the changes from digital transformation and the sheer amount of events produced from these data stores, applications, services, and complex environments, organizations are experiencing alert fatigue and struggling to detect and respond. Security is now at the forefront of every business decision. So along with all the optimizations and efficiencies that we have been discussing, digital transformation also comes with its share of challenges. At minimum, I will need to redesign my network. I could try to do a lift and shift, where I take an application in its current state and try to push that to operate in a cloud, but this might also bring along a lot of the inefficiencies I'm trying to get away from. I can redesign the applications and environment to use a lot of the cloud-native components that we have been discussing, but that takes time. And there will also be some element of resources that will remain on-prem. Take mainframe, for example. Some things will never run in a public cloud environment, and this leaves us with a perpetual hybrid state, where we now need to maintain and manage resources both on-premise and potentially in multiple public clouds at the same time. Trying to find the right people and the resources to manage this is a new challenge, and there is a new threat vector as well. Take the admin keys to access a cloud account, for example. If these are misplaced or accessed in an inappropriate way, the entire region for that business can completely be compromised or evaporate. The same could be said for application architecture. We now have an increased footprint of microservices, and with that increased exposure. We now more than ever need to look at internal communications or east-west traffic inside the network as opposed to just north-south, which is the ingress, and look at microsegmentation and how authentication and authorization are managed at scale across all of these services. We need to use new methods for troubleshooting and traceability, understanding what users are accessing what data through what shared services, and identifying anomalous behavior can be more challenging, as we have seen with a number of data breaches and the response times and detection times of 200 days to detect and 70 plus days to respond. For API first development, you have new skill sets that are required to develop and manage these environments. New development frameworks like React.js, React Native, Angular, and Jamstack, along with them come new threat vectors. And we also don't know what we don't know. It's hard for organizations to keep up from a skill set perspective, as there are a lot of opportunities to innovate, but so few people to fill those roles, especially people that are security proficient and aware. We have new API threats as well, including mass assignment, insecure resource access, broken function level authorization, and more. And lastly, when it comes to automated deployments, we want to make sure that the approach that we are taking, that we have the resources to back that up, and that we're going to be able to sustain this. Are we using a different deployment pattern unique to each environment, or is there a way to have one universal approach for all environments? And how does security fit into each of these parts of the technology deployment and development lifecycle? Going back to topologies, we have inside users and we have external users. We need to make sure that we understand what these users are doing, and we need to monitor and manage that access. Position ourselves to be able to identify something anomalous or malicious, especially when the environment is complex, and if you're an organization that processes sensitive data or can be a target of attacks. For outside attacks, we have volumetric and we have DDoS, also the ever-changing bot landscape. Over 60% of externally facing traffic is automated, 30% is malicious. For internal attacks, we need to monitor privileged users, the fox who guards the henhouse, and also take into consideration things like compromised credentials, looking for malicious or anomalous behavior in managing the environment or even accessing sensitive data. There also needs to be a strategy to put all of this event data together into something that is useful. Typically there's a strategy to leverage a SIM, but the sheer amount of data and events can drive costs to an unsustainable level. Organizations have event fatigue and alert fatigue, where even though they have all this data in one place, it's difficult to be able to make use of it. We need to position ourselves to be able to proactively detect incidents and respond and remediate, where we can focus on the events that matter, that are sensitive or had risk, and be able to take appropriate action. Going back to our primary goal, which is to protect our sensitive data and all paths to that data, including applications and APIs, the typical approach is to put an appropriate technology in place at each tier in the environment. For Edge, something that will handle both web-based and volumetric attacks and manage the bot problem and cache content. Also something to monitor traffic inside the network, like web application firewalls that can inspect traffic for internal sites or web properties or sites accessed over private connections. Also runtime protection that will ship with the application code itself, mitigating code vulnerabilities, OS command injection, and even local access to those applications, making those applications run secure by default. And then there's monitoring and audit on the back end for all of our data stores and databases. This is a great story, but the devil's in the details, and we need to talk about how this is deployed and how it is managed with automation at scale. This is a topology diagram we can use as an example of an application being deployed in Amazon using some of the more modern technologies we've been discussing. What's important to hone in on here is the way that security can be baked directly into this process. In this case, we have application code or binaries that is being committed to a deployment archive or Git repository. Now we need an environment to deploy this into. In AWS, I'll first have to select a region, and then I'll do a few things. Let's create a VPC, or virtual private cloud, where I'll need to define some subnets, routing configurations, create identity and access management or IAM roles to allocate permissions, create ACLs and security groups to determine how these assets can be accessed, and then create a place to deploy my application. In this case, we are looking to containerize this application, so we might use AWS Code Pipeline to automatically create a new container with each code commit. There are other pipeline technologies out there from Bitbucket or GitLab or even Jenkins as a build server, which can help automate the build process on each commit. This is all part of our automated workflow. We will want a container registry to store these containers as well. Although there are a variety of registries we can use, in this case we use Elastic Container Registry or ECR native to AWS. To deploy the container, we may want to use a container orchestration solution like Kubernetes, which can be made available as a service as well, but in this case we're going to deploy our container into Elastic Container Service called Fargate and specify replica sets to scale up based on load. And we're going to make the application accessible over the web with an application load balancer or ALB. The application needs a database, so we're going to use a hosted database service running on RDS. If I want to automate setting up the environment, I could use something like CloudFormation, which will automate the creation of many components in Amazon, but the CloudFormation technology is proprietary to AWS. And what if I need to move this application and this entire environment to VMware ZSX or Azure or GCP? In this case, we have selected Terraform, which is a cloud-agnostic provisioning tool from HashiCorp referred to as infrastructure as code. Essentially, I define a few configuration files, and I run Terraform init, Terraform plan, and Terraform apply, and my entire environment is stood up as a template or a module where I can pass in parameters that are environment specific. Now let's add on security. This is an externally facing site, so we will need DDoS protection, bot protection, and web application firewall protection. I will need to set that up mapping back to the ALB endpoint. If the security vendor supports Terraform, we could simply add some extra lines in our Terraform configuration files to add DDoS support, bot protection, and web application firewall protection to be stood up and torn down along with the application on the fly. This can include all the security policies, certificate management, content cache settings, application delivery rules, and routing rules, etc. Since the application will be pushing sensitive data into our database, we will need to monitor access to comply with regulatory audit and compliance requirements. I will also need to continually classify that data in the database to understand exactly where this data sits and if it changes over time. If the data security solution supports it as a part of our IAM configuration, we can simply grant the data security solution access to the VPC to automatically discover the database when it's created, ingest the audit data, and perform the classification scans as a scheduled job to see where my sensitive data is over time, or to classify that based on the audit data that's produced. For application protection, you'll notice that the RASP technology and configurations are committed directly into the application code itself. In this case, RASP can run in an air-gapped environment and doesn't need any external network access. So no matter where the application goes, if it's on bare metal, virtualized, or containerized, it will be shipped with and security right inside the code base of the application itself and will be secure by default. Also, in the event you incorporate functions as a service like Lambda with technologies like API gateways as a part of your build or application design, it would be a good idea to also include runtime protection there in your Lambda code as well for consistent and comprehensive code coverage. If there is an API gateway in the environment and the security vendor supports it, the schema of that API can be output into the edge solution to create a positive security model to only allow valid traffic back to the API gateway, reducing utilization costs in Amazon. This API gateway integration can also be tied into your CI/CD process as well to execute on each configuration change of the API gateway. Organizations have to go through different variations of its deployment process hundreds or even thousands of times, and it changes over time as new services are introduced and application architectures evolve. So this process needs to be 100% automated to be able to scale. Security cannot be an afterthought. The Imperva Sonar platform is able to protect all workloads and data anywhere. For Edge, DDoS protection with an industry-leading 3-second SLA and application performance enhancement with global CDN capabilities. For application security, industry-leading bot management, API protection, and web application firewall capabilities, as well as runtime protection, making applications secure by default in any architecture, including functions as a service like Lambda. Database security, protecting over 140 different database service types, covering on-premise or cloud-based, all flowing back into a central Sonar platform with behavioral analytics, orchestration, and automation, reporting capabilities, making it easy to focus on the events that matter and giving you the ability to take action from the events. Imperva integrates with all major vendors in the industry and makes this easy to deploy. Imperva is a 7-year consecutive leader in the Web Application Firewall Magic Quadrant since the inception of this space. But Imperva has always had a charter to protect sensitive data and all paths to that data. This includes API security, application security, and data security as well. As we have discussed in today's session, applications exist to get to data, and it's important to have a holistic approach to both, whether on-premise, in the cloud, or in hybrid environments.